Hi everybody. This lecture is going to focus on sampling. Just to give a quick definition of what a sample is, and I'm sure all of you know this, but let's just start at the very beginning. So a sample just means that rather than collecting data from all of the people in the population that you're interested in, you are only going to collect data from a group of people within that population. So for instance, at NKU, we have between 14 and 15,000 students. Instead of surveying every single one of those students, we may just collect data from a sample of those students. We may, for instance, say we want a sample of 500 NKU students. That, of course, makes data collection as well as data analysis a lot simpler when you have smaller sample sizes. Okay, so once we now know what a sample is, the next question is, how are we going to collect data from this sample? What sampling strategy are we going to use to select the people that will participate in our study? There are two main ways that we can collect data. You can use non-probability sampling and you can use probability sampling. So those are the two main ways that we will select the population from which we're going to collect data. Non-probability sampling means that you are going to select your sample without relying on probability theory or random selection mechanisms. This approach is definitely less resource intensive than probability sampling, and it is very commonly used in the social sciences. So there are many journal articles that are published. In fact, probably the majority of journal articles that are published do not use probability sampling. They use non-probability sampling. Now the big downside, so the upside is it is more it's more resource efficient, so it's less time intensive and less costly to do non-probability sampling. That's the good news. The bad news is that when we use non-probability sampling, our findings are not representative of the population as a whole. So in other words, when we use non-probability sampling, all we can say is that our findings are true for the sample that we collected data from. So if we collected data using non-probability sampling from 500 NKU students, and we found that 80% of those students are satisfied with NKU, all we can say is that 80% of the sample of NKU students were satisfied with NKU. We would not be able to generalize that to all NKU students. So we would not be able to conclude from that study that 80% of all NKU students are satisfied with NKU. So that's the big downside. When we use non-probability sampling, again, non-probability sampling means that we select our sample without using probability theory or random selection mechanisms. When we use non-probability sampling, the big downside is that our findings are not representative of the population from which we drew our sample. So our findings are only true for that specific sample from whom we collected data. On the flip side, we have probability sampling. So with probability sampling, you do rely on probability theory and you do use random selection mechanisms. So when you use probability sampling, the probability for every person in your population to be selected for study participation is known. And as a result, the findings are representative of the population as a whole. So for instance, if we used probability sampling to collect data from 500 NKU students, then the findings from our study would actually be representative of all NKU students. So in that case, we would be able to generalize our findings to all NKU students rather than only being able to say that it's true for our own sample. So what that means is that probability sampling is definitely the desirable one. It's the best one of the two. However, sometimes for a variety of reasons, whether it's availability of resources, availability of time, regardless of the situation, sometimes probability sampling just isn't an option, and in those cases researchers will use non-probability sampling. But again, if you have the option to do probability sampling, that's definitely the better one, since it allows you to have findings that are representative of the entire population rather than only being representative of your sample. Now, there are different types of non-probability sampling and different types of probability sampling, and we're going to go through a few for each. So the major types of non-probability sampling are convenience sampling, purposive sampling, quota sampling, and snowball sampling. Those are the four main ones. Convenience sampling, that refers to when researchers select certain participants simply because they're convenient and they're readily available. So a lot of times, for instance, in psychology, undergrad psychology classes, students may be asked to participate in a survey for their faculty member, and that's happening because those students are conveniently accessible to that faculty member. So it's not that those people that you're surveying have to have some specific character in common. No, the reason why you're asking them to participate is because they are conveniently accessible to you as the researcher. So again, makes sense. Convenience sampling means that those people are conveniently accessible to you. Purposive sampling is the next type of non-probability sampling. With purposive sampling, respondents are selected with a specific purpose in mind. So those respondents are selected for participation because they share a certain characteristic. So for instance, if I wanted to collect data specifically about NKU students, and I went out on the plaza and started asking people to complete my survey, that is non-probability sampling. I'm not using any type of probability mechanisms to collect or to figure out who's going to participate. I'm just going out on the plaza, and anybody that's out there that says they're a student, I'm asking them to participate. So in that case, that would be purposive sampling because I'm asking them to participate because they share that characteristic in common of being an NKU student. Okay, then the next one is quota sampling. Quota sampling, again, is a non-probability sampling approach. It could be viewed as a type of purposive sampling. In quota sampling, what you're trying to do is you're trying to meet predetermined quotas. And that can be either a proportional quota or a non-proportional quota. So let me give you an example. Let's say you wanted to collect data from NKU students on campus, and at NKU, 60% of students are women and 40% are men. You may want that gender proportion to be reflected in your sample as well. So you may say, okay, when I collect data, I'm going out on the plaza, I'm going to collect data, and I'm going to make sure that 60% of the surveys that are completed by women and 40% are completed by men. That is a form of quota sampling, and it would be considered proportional because I'm trying to mirror the gender proportions in my sample that we find in the overall community of NKU students. On the flip side, I might say I don't really care about the actual proportions in our community. I just want to make sure that half of my sample is male and the other half is female. So in that case, it would be non-proportional, and I'm just going to make sure that half of the surveys that I collect are from men and the other half are from women. So that's quota sampling. And then the last type of non-probability sampling that I wanted to bring up is snowball sampling. Snowball sampling is a pretty unique way to collect data. So in snowball sampling, the researcher will approach one or two, just a handful of participants that meet the criteria for inclusion in the study. And you'll ask those participants, would you be willing to participate in my study? And if they say yes, you would engage in the research with them, whether that's a survey or focus groups or an interview. You would conduct your study with them, and then at the end, you would ask them, do you know of anybody else that might be interested in participating in my study? And you ask them for recommendations of other people that they believe would be interested. This is a great type of sampling to use if you're trying to collect data from pretty closed-off populations. So for instance, if you want to go into Appalachia and collect data from individuals who have experienced domestic violence, that's a very difficult population to collect data from because those individuals would be very private, would be unlikely to want to share their story with a stranger. However, if I can get one or two people on board who trust me and who are willing to participate in my study, then they may be able to recommend that other people participate in my study. And because those other people trust the initial participants, they may choose to participate as well. So again, the term snowball just means, you start with a smaller sample, but the idea is that it would snowball into a little bit of a larger sample. To be clear though, with snowball sampling, you're never really striving to get a huge sample. It's usually used with qualitative studies, and so if you could just get maybe 10 to 20 participants, that would already be great. So those are the four main types of non-probability sampling. So convenience sampling, again, means that people are asked to participate because they're readily available. It's convenient to ask them. Purposive sampling means that you're looking for participants who share at least one characteristic in common. So that might be that they're an NKU student. It might be that they've experienced domestic violence. Whatever it is, it's one characteristic at least that they share in common, and that's why you want them to participate in your study. Quota sampling, again, means that you want to meet certain quotas that can be proportional or non-proportional to your overall population. And so you want to meet quotas usually in terms of demographic characteristics like gender or ethnicity or sexual orientation. And then the last one is snowball sampling. Again, that's the one you would use if you have populations that are more challenging to collect data from. And here you would get 1 or 2 people on board to participate in your study, and then you would ask them to recommend other people to you who may be willing to participate. All right, moving on to the types of probability sampling now. So again, with probability sampling, there you are using probability theory to collect your sample. And as a result, it allows you to collect data and have findings that are representative of your entire population rather than only being representative of your sample. The 4 main types of probability sampling are listed right here. So simple random sampling is probably the best type of sampling you could use because it is the most random. With simple random sampling, every single person in your population has the same probability or chance of being chosen. So in this case, what happens is you would have a list of the entire population, and people would be randomly selected off of that list. So at NKU, that would mean that you would have a list of every single NKU student, and you would have the computer randomly select however many people you want to have in your study. So let's say 500 people, you have the computer randomly choose 500 individuals off of that list. Aside from just randomly choosing off of a list, simple random sampling is also accomplished through random digit dialing. A lot of the bigger polling companies, like for instance Gallup is one of the best known polling companies, they use random digit dialing, so their computers literally dial random phone numbers and reach individuals in that way nationally or by state, by county, whatever is needed for their particular study. So again, simple random sampling is fantastic because every single person in your sample, every single person in your population has the same chance of being chosen to participate. So it is the most random that you could possibly get, and therefore it's a very desirable type of probability sampling. The next one is systematic sampling. With systematic sampling, you would get a list of everybody in your population, and then you would choose every kth person from that list. So for instance, if you have a list of all NKU students, let's say we have 15,000 NKU students, and I would choose every 100th person off that list. So the 100th person would be on my participation list, the 200th person, the 300th, the 400th, etc. And in that way, I would end up with a sample of 150 people by choosing the 100th. Every 100th person off the list is added to my sample. So that's systematic sampling. Stratified random sampling is similar to quota sampling, which we just discussed. So quota sampling was the non-probability approach where you try to meet certain quotas. Stratified random sampling is the exact same, except that it is a probability approach where you do use probability theory to collect data from your sample. So with stratified random sampling, you would, again, divide your population into distinct subgroups. So for instance, by gender, you would create a list of all of the people in those subgroups. So for instance, at NKU, all of the men and all of the women. And then you would randomly select a certain amount of men and a certain amount of women off that list to either have the same proportions as in your overall population or different proportions. So again, you could say, okay, if you're collecting data from 100 people, you're going to make sure that 60 of those people are women and 40 of those people are men. That way you're in line with the proportions that are actually true in our overall NKU student body. Or you could make it disproportionate, in which case you would just say, I'm going to make sure that 50 of my participants are men and 50 are women. So again, that's stratified random sampling. And then the last one here is cluster sampling. Cluster sampling is what you use when you do not have an entire list of all of the available people in a certain population. That happens quite often, that we don't have this perfectly assembled list of everybody that belongs to a certain population. In that case, you can use cluster sampling. So what you do there, for instance, is you might say, okay, I'm going to randomly pick 10 of the 50 states. And then for each of those states, I'm going to randomly pick 10 counties. And then for each of those counties, I'm going to get a list of the people living there, and then I'm going to randomly select 100 people in each of those counties. And that way you're building your sample up by first breaking your population down into different clusters. So again, cluster sampling is what you would use if you don't have access to a complete list of all of the people that belong to a certain population. So those are the 4 types of probability sampling. Again, simple random sampling is probably the best because it is the most random. In that case, every single person in your population has the same likelihood, the same chance of being chosen for study participation. Systematic sampling, also probability sampling. In that case, you're going to choose every kth person from a list, every 100th person, every 10th person, every thousandth person. Stratified random sampling, again, means that you will try to meet certain quotas. Again, that can be proportional or disproportional. And then cluster sampling means you use that when you don't have a complete list of all the individuals that belong to a certain population. So you're going to break the overall population down into smaller clusters for which you can obtain lists. Okay. When you are using probability sampling, there are 2 statistics that play a role in determining what sample size you should use. And those statistics are sampling error or margin of error. Both terms are correct. Sampling error and confidence level are the 2 statistics we look at when we try to figure out what sample size to use. Again, this is only when we're using probability sampling. You do not have to worry about this with non-probability sampling. But with probability sampling, we look at sampling error and we look at confidence level. I'm going to go through these 2 definitions first, but then I'm going to give you an example that hopefully will drive the point home. So sampling error has to do with the accuracy of your findings. So a pretty common sampling error that you would find, for instance, with the Gallup, is a sampling error of 3%. What that means is that if you were to collect data from your entire population rather than just your sample, if you were to collect data from all of the people in your population, the findings you would get would be within 3 percentage points of what you found within your sample. So what that means is that your findings are very accurate, because even if you were to survey every single person in your population, your findings really wouldn't be that much off. They would only be off by 3 percentage points either way, plus or minus 3 percentage points. The lower you want your error to be, your sampling error to be, the larger your sample has to be. So that's something to keep in mind. 3% is pretty much the lowest you'll see. If you want to go lower than 3%, you have to increase your sample size considerably, and it ends up not really being worth the extra resources. Then confidence level. The confidence level is a statement of how often you would expect to find similar findings if you were to repeat the survey, if you were to repeat the study again with a different group of people, with a different sample, how often would you expect the findings to be in the same range? In other words, how often would you expect your findings to fall outside of the margin of error if you were to repeat the study? So let me give you an example, because I think that will help a lot, because those two terms are pretty confusing. And actually, let me go back really quick. I want to point out that the sampling error and the confidence level are independent statistics. So it's not because your sampling error is 3% that your confidence level is 97%. They do not add up to be 100. They might, depending on your study, but they don't have to. So the most common sampling error that you'll find, for instance, in the Gallup, so in very nationally representative studies, is 3%. The most common confidence level that you'll find in those types of studies is 95%. So these two statistics, even though they impact each other, they are independent from one another. So here we go with the example. The Gallup, again, as I mentioned, they do national polls very regularly. Around election time, you will hear Gallup poll predictions pretty commonly. The findings from Gallup are very trusted, very accurate. They do a great job with their sampling. They use simple random sampling regularly. Sometimes they might actually try to make their findings more representative of certain quotas. That's possible, but oftentimes they'll just do random digit dialing. Recently, the findings I'm going to give you here as an example, recently the Gallup looked at U.S. patriotism. The study was conducted in July of this year, and their study found that, for this, at this point in time, their findings were this 4th of July, and I'll put my cursor right here, this 4th of July marks a low point in U.S. patriotism. For the first time in Gallup's 18-year history, asking U.S. adults how proud they are to be an American, fewer than a majority say they are extremely proud. Currently, 47% describe themselves this way, down from 51% in 2017 and well below the peak of 70% in 2003. So again, what they found in this study, and the study had 1,520 adults in it, so they surveyed this many adults in the United States, and among that sample, which is nationally representative, among this sample of adults, they found that 47% currently, or at that time, described themselves as extremely proud of being an American. In 2017, it was 51% that said that they were extremely proud, and in 2003, it was 70% that said they were extremely proud to be an American. So also, if you look up this report, and the link is actually provided in the PowerPoint if you look in the footnotes. So in this report from Gallup, they go on to explain their methodology. So they say telephone interviews, so through random digit dialing, conducted between June 1st and 13th with a random sample of 1,520 adults, 18 and older, living in all 50 states and the District of Columbia. And then they go on to say that for this study, the margin of sampling error is plus or minus 3 percentage points at a 95% confidence level. So what this means, the sampling error of plus or minus 3% means that if instead of sampling this 1,520 adults, if instead of doing that, we actually sampled all adults in the United States, then our findings would be between 44% and 50%. That's that 47% that they found in the study right here. 47% plus 3% would be 50%. Minus 3% would be 44%. So again, if instead of just surveying these 1,520 adults, we surveyed every single adult in the United States, our findings would be between 44 and 50% of people would say that they are extremely proud to be an American. So really what that means is that the findings from this study, even though they only collected data from 1,520 people, those findings are extraordinarily accurate. They very accurately represent the opinions of all adults in this country. So that's what the 3% sampling error means. Again, it means that if you were to sample everybody in your population except instead of just your sample, that your findings would be within 3 percentage points of the study's findings. Then in terms of the 95% confidence level, what that means is if we were to repeat this study 100 times, so 100 times we would collect data from different adults. So again, still 1,520 adults, but we'll pick different ones. If we were to do that 100 times, then 95% of the time, our findings would be between 44% and 50%. So out of the 100 times that we repeat it, only 5 times would our findings be outside of this range. So again, it means that if we repeat our study over and over again, this shows how consistent our findings would be over the course of all of those repeated studies. Again, the Gallup is very, very accurate, and the sampling error, again, means that it shows you that rather than if you only sample these 1,520 adults, if you sampled everybody in that population, so all adults in the United States, then your findings would be within 3 percentage points of the findings from the study. And if you repeated it 100 times, that confidence level of 95% means that out of those 100 times that you repeat it, 95% of the time, your findings will be within this range. So again, just to reiterate, that shows that even though these two statistics are related to one another, they do not add up to 100. They impact each other, sure, but that does not mean that the sampling error plus the confidence level equals 100. That is not the case. Okay. I have some practice questions for you, and then we'll be done. So this is just to check your understanding. So this first question says, I want a representative sample, and I also want to make sure that I have an equal amount of men and women in my sample. What sampling strategy should I use? So when you look at this again, I'll repeat it. I want a representative sample, and I also want to make sure that I have an equal amount of men and women in my sample. What sampling strategy should I use? So the key words to look at here is you want it to be a representative sample. If you want it to be representative, it has to be probability sampling. So that automatically rules out the top 4 options. So now we're looking at these 4. Then the next key is that it says that they want to have an equal amount or an equal proportion of men and women. So out of these 4 probability sampling approaches, the only one that really focuses on different proportions is this one right here, the stratified random sampling. Okay, moving on to the next one. The description reads as follows. I want to examine mental health among partner violence victims. I go to one women's shelter to recruit participants. What sampling strategy am I using? So again, if you're only going to one women's shelter, it doesn't say anything about being a representative sample. So we have to assume that it's non-probability at that point. So now we're ruling out the bottom 4. We're trying to make a choice between the top 4. And what we know is that it says that we want to make sure that we're looking at partner violence victims. So that's the characteristic that these people share in common. So since they all share one characteristic in common, and that's why we're recruiting them from the women's shelter, that would make it so that the answer is B, purposive sampling. Next, I want to obtain a nationally representative sample of social work students. However, I am unable to get my hands on a list of all social work students nationwide. For this reason, I will be randomly selecting certain states and then randomly selecting certain social work programs within those states. Subsequently, I will get lists of students within those programs and randomly select students from those lists. What sampling strategy am I using? Again, we start off by noticing that it's nationally representative, and it actually says randomly selecting, so we can again rule out the top 4. We know it's got to be a probability sampling approach. And then we also know that they are dividing it up into different clusters, right? The researcher is first selecting states, then selecting social work programs, and then selecting students out of those social work programs. The only one that fits that bill is H, which is cluster sampling. Okay, I believe this is the last one. I would like to examine caffeine consumption. I ask the students in my class to complete my survey. What sampling strategy am I using? So in this case, again, it doesn't say anything about a representative sample. It just says that I'm going to ask people in my class to complete a survey on caffeine consumption. In this instance, again, we can rule out all of the probability options, so we know it's one of the top 4. It also doesn't say anything about that we're looking at a specific group of people. It doesn't say anything about meeting certain quotas. So in this case, we know that really the only reason I'm asking people in my class, that I'm asking my students to complete it, is because it's convenient. And that then places us squarely with option A. Okay, so that's all I have for you on sampling. I'd be happy to answer any questions if you have any about this, and I hope all of this sits well with you and that it all makes sense. Thanks, guys. Bye.